So hello everyone. So today let us see the variable inductance transducers. There are different types of transducers which comes under the variable inductance transducer. We'll see one by one how it works with respect to the sensors and transducers. So basically, whenever we say that a variable inductance, so if you observe here, it's based on the change in the magnetic characteristics. So mean to say, whatever the core I'll be using, so I'll be varying the core of the inductor such a way that I'm varying my inductance value. So this core variation can happen linearly or in the form of rotation or any other displacement which will be given. Based on that, it can move, the core can move linearly or in a circular way. So based on this movement, the inductance is gonna vary. That is called as a variable inductance transducers. So we are aware of that, the transducer which converts the non-physical quantity to the electrical quantities. So basically here my displacement or the rotation, which is my non-physical quantities, which will be converted to the electrical signal over here. So right now if you observe here, so the electric circuit is response to measure. It may be displacement, velocity, acceleration, etc. It could be anything. So as I mentioned here, these variable inductance or inductive transducers are classified into two types. One is self-generation and another is a passive type. So the name itself is saying it's a self-generation. In this type, the voltage is generated because of the relative motion between the conductor and the magnetic field. So what is happening here, what mechanical input you are giving for the transducer, based on that input, the relative motion between the conductor and the magnetic field. So because of this, the voltage is generated. It is called as a self-generating type. Whereas the second one, in this, the motion of the object results in change in the inductance of the coil of the transducer. The motion of the object result. So what object you are gonna connect, so mechanical input, that movement, if it is changing, based on that the inductance will change. That is called a passive type. So self-generation, which generates a voltage within that if there is a relative motion between the your conductor and a magnetic field here. So based on this, there are subdivided once again the self-generation. One is electromagnetic type, electrodynamo type, eddy current type under self-generation, where it generates a voltage. So there is passive type, where we have a variable reluctance, mutual inductance and differential transfer type. We will see one by one here. The first one, that is a electromagnetic type, so self-generation type. So here if you observe that, coming to the construction part here, so this is a core which is called a permanent magnet core, which has a north and south pole here, and on the permanent magnet the coil is wound here. If you observe that, the coil will be wound here. And there is another magnet which is called a ferromagnet, which is the other part of the entire core, where you can see the magnetic field path, we can say, which will be completed through this ferromagnet and a permanent magnet. So here, whatever the mechanical input we has to be given, so with respect to displacement or velocity, so that has to be connected to the ferromagnet. It will be connected to ferromagnet. Whenever mechanical force, any displacement is applied, so this ferromagnet will be moving. So if you look at the direction here, based on this direction, it can move downward or it can move upward based on the mechanical input. So because of that, what happens, the flux which is linking within the coil, what happens, it's gonna change here. The EMF induced with the flux induced within the coil, or EMF induced within the coil, is gonna change because of the change in my inductance, because of the variable inductance. Hence the output voltage V0, so this V0 will be proportional to the mechanical input, which will be force or displacement or velocity, whatever the input will be given here, it will be proportional to that. This voltage will be proportional to that one. So this is how the EMF will be generated, and it will be measured, the output voltage will be measured based on this one. This is called as a electromagnetic type. So another type is a self-generation type is electrodynamo type. So here electrodynamo type are two types. One is for linear movement and the for a rotational movement. The same principle applies here also. Once again I have a permanent magnet. So where you can see this one. So this is the permanent magnet, north and south pole, and I have a at the center I have a one more core, which is a movable core I can say, and the coil is present on this movable core. So once again the mechanical input will be connected here. So based on your mechanical force applied, the movement of this core is going to happen. Once the core moves here, the flux induced is going to change, hence the inductance of this value is going to change. So based on that, the output voltage is going to also change. This is for a linear variation. If it is a circular motion, look at here in this diagram, it is connected for a shaft. On the shaft of the of a device, so where it consists of an iron core and it consists of a coil also. If you observe here, it consists of a coil also here. Right? There are coil present. So whenever it rotates, so this coil is placed between the magnetic field. So where I have a magnetic field here. If you observe here in the north and south magnetic poles are present, the coil is present within this. So whenever this coil cuts the magnetic field, the EMF will be induced in this, that will be measured with respect to the V0. So this V0 will be proportional to the rotation which is going to happen with respect to the mechanical input. So this is regarding the variable inductance stands as a self-generation type. Thank you.